Welcome to HVAC Startup Technicians, and today we're going to talk about CFM on a heat kit. I'm going to go through the steps to show you exactly how we calculate our CFM on our heat kits. So let's get started. So to calculate our CFM on our heat kit, it's the formula we're going to use today is volts times amps times 3.41. So I'll go ahead and I already look at some volts, and it says like if we have 240 volts times 41 our amps times 3.41, that's gonna give us 33,554. So that's gonna be our output. Now that is the first part of the math. The second part of the math is our delta T, which is taking the difference between our return and our supply. I had a number down at 35. So you're going to take that 35 times 1.08. That will equal to 37.8. And we're going to actually divide those two numbers. So based on these numbers, just looking at what we have there, we see we're having 887 CFM. So that's the way how you actually calculate what your heat kit is doing. I know last week I talked about BTUs and we talk about how to work out our CFM. But what I'm talking about now, it's how to tell the CFM from a unit using those numbers that is actually running. So I'm going to recap before I move forward. Is volts times amps times 3.41. And that's the first part of the math. And the second part of the math, we're going to take our delta T times 1.08 and we're going to do a little bit of division. And that's how we will get our CFM on our heat kit. Let's talk a little bit about our CFM on a regular furnace, a regular gas furnace. So to figure out that, we're going to first tell you how we're going to work out your BTUs, how to figure out how much BTUs that system is running, which we're going to take our CFM times our delta T times 1.08. That will give us our BTUs on our regular gas furnace. And that's with the system running, how to figure out how much BTUs. And just to go a little bit further, if you want to know your efficiency of that unit, you go take what you have from what you need. So you're going to look at the back of that unit and see how much your BTU should be, and you go just make that, you go just do that mathematics. You just take off from what you have from what you need, and that will give you your efficiency, and which will tell you exactly how efficient the system is running. Let's also talk about BTUs on a cooling system. Our BTUs on our cooling system, I'm just talking about what we have on our outside unit. Just calculating the BTUs, we're going to take our CFM times our delta H, now because we're dealing with cooling, times 4.5. And that will give you what your BTUs are. So these are some numbers you can play with. CFM times delta H times 4.5. You're working your BTUs exactly on what you have outside. As I said, you will know definitely for our 400 CFM per ton and our 1200 BTU per ton, making the equivalent. But with a system running now, we're talking about a system running, we're not talking about design. CFM times delta H times 4.5. Want to get a little bit deeper into with the efficiency size part of it, how to figure out what's our output, what a system is doing. I did talk a little bit about this in a previous video, but I just wanted to get into a little bit more detail. So if we have a 80% furnace, and I'm going to work with a 80% and figure it, and I'm going to try to show you exactly as a ballpark what your CFM should be. You will take 0.80 times 80,000, because I'm working out that that's a 80,000 BTU furnace. If you do that multiplication, you're going to get 64,000. That 64,000 is your BTU output. Okay, so that again is one part of the math with a system running, what that system is doing. The second part of the math is I'm going to take what is my delta T, which I have on the board. I have 45 times 1.08. That is the second part of the math. It's very important to understand that we're talking about a two-part math on a system that is running. So let's recap. 0.80 times 80,000, which is a 80,000 BTU furnace. 64,000 is my output. That's my output, my BTU's output. And then I take my 45 times 1.08, that's give me 47.6. So what we're going to do, we're going to take our 47.6 and divide it by 64,000, and I have 1,344 CFM when that system is running. It's a good way to figure out what the system is doing when the system is running. Just let's go back and let's talk a little bit about furnaces and how to figure out our design. We know on an 80% furnace, we need 130 CFM per every 10,000 BTUs. So a good rule of thumb to work out that is you take 130, and we was talking about an 80,000 BTU. We'll multiply that times it, and that will actually help you see how much CFM you need. But that is not actually telling you what it's doing. What we did a while ago is tell you what the system is doing. But this part of the math is still important because this part of the math goes with designs. So you should actually know what's happening on your design. Same thing with the 90%. We take is 150 per 10,000 BTUs. So if we had that 80,000 and that was a 80,000 BTU furnace and that was a 90%, we will take that, we will now use 150 instead of 130, and we will do that times 8, and that will tell you what we need for our CFM. And also another tip I want you to remember, static pressure up, CFM down. So you actually want to make sure that we have good static pressure in your unit. All right, guys, thank you for watching the video. Please don't forget to comment and subscribe. And next week, we will give you more information as we continue to do more in this series of how to figure out BTUs and CFM. Thank you.